Part B, a catalyst has been added. Now, a catalyst, we recall from our kinetics unit, speeds up a chemical reaction by lowering the activation energy. And if you think of a potential energy diagram, potential energy over time, this is an endothermic reaction, so our products have more energy than our reactants. Our activation energy is this hill, EA. If the catalyst lowers the EA, then it's going to speed up the forward direction, definitely, but it also speeds up the reverse direction because both the forward and reverse EAs will be lower in the presence of a catalyst. So we'll say here the catalyst speeds up both the forward and reverse reactions. Since it's speeding up both the forward and reverse, therefore there will be no shift in equilibrium. If it had sped up just the forward direction, then the forward reaction would predominate and we'd make more products. If it sped up the reverse direction, then the system would shift reverse, we'd make more reactants. But if both are sped up, then there's no shift in equilibrium, so there's no change in the O2. Okay? Now the third example, third question, says the system is heated. Now the reaction here is endothermic, so heat was a reactant in the forward direction. Heat is like a product in the reverse direction. Now if we heat the system, then we're adding heat. So the system tries to remove heat. Another way to say that is the system tries to cool down. Now we can look at this reaction again at the top of the page. If the reaction were to shift in the reverse direction, if it shifted from SO2 and O2 back to the SO3, then it would be producing some heat. And we remember that when a reaction produces heat, it feels hot. Well, the system's not trying to produce heat. It would like instead to use up some heat to cool down. So that means that the reaction is actually going to shift in the forward forward direction. In shifting forwards, the heat will be a reactant, and some of the heat that we're adding will go into making products, and so the temperature will lower. So shifting forward, they will get, in the end, more O2 produced. You might recall from the little musical video that we watched on YouTube about equilibrium, there's a simple way to remember this. If you add heat to an endothermic process, you make more products. Okay? If you add heat to an exothermic process, you make more reactants. So if you'd prefer to just memorize that, you can. The system shifts away from the substance you're adding. So adding heat, the system will shift away from heat towards the products. If the heat were on the product side in an exothermic process, adding heat, the system would shift away and that would be back towards the reactants. Okay, so that might be useful for memorization purposes. Unfortunately, that's not a good explanation for an essay question, so don't tell me the system shifts away from heat. Give me an explanation similar to the one that we've given here.